Hi Year 12. Today what we're looking at is normal distribution. So the normal distribution is a special continuous probability distribution. Its probability density function is often called a bell curve because of its shape. The mean, mode and median are equal at the centre of the probability density function as shown. So there are many examples of data that are normally distributed, such as IQ, birth weights, ages, reaction time, and exam results in school. We use the population mean, mu, and standard deviation for the normal distribution. So to graph a normal distribution, in a normal distribution, most of the dates lies within 3 standard deviations of the mean, with the mean in the centre. So our mean is here, and then this is 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. This is 1 standard deviation below the mean, 2 standard deviations below the mean, and 3 standard deviations below the mean. So for our first example, we have a set of data is normally distributed with a mean of 8.3 and a standard deviation of 1.2. Sketch the probability distribution function. So the probability distribution function is here. You just need to write the numbers down here. So our mean is 8.3. So our mean is of 8.3 is here. And then our mean plus 1 standard deviation is 8.3 plus 1.2, which equals 9.5. So 9.5 will go here. We then have our mean plus 2 standard deviations. So it'll be we can just go 9.5, or we can go out 8.3 plus 2 lots of 1.2, which equals 10.7. And then we have our mean plus 3 standard deviations, which is our mean of 8.3 plus 3 lots of 1.2, which is 11.9. We then have our mean minus 1 standard deviation, so it'll be 8.3 minus 1.2, which equals 7.1. We have our mean minus 2 standard deviation, so that will be 8.3 minus 2 lots of 1.2, so that will be 5.9. And then finally, we have our mean minus 3 lots of standard deviation, so it'll be 8.3 minus 3 lots of 1.2, which equals 4.7. For example 2, we have a normal distribution has the probability density function below. Find its mean and standard deviation. So the mean is always at the highest point. So in this case, our mean is going to be 15.6. To then calculate our standard deviation, we'll have our mean plus 1 standard deviation is 19, which is this value here. So then to find our standard deviation, it equals 19 minus our mean of 15.6, which is equal to 3.4. What we then do is we check that this is correct. So 15, just in our heads, we don't have to write it down, but we should check that all of the difference between the values on the graph are 3.4, and for this example, they are. So the normal distribution can have different shapes depending on the size of the standard deviation. In the diagram, the green curve shows the normal distribution with the highest standard deviation here. So standard normal distribution. It is difficult to find probabilities in the normal distribution by integration because of the equation of the cumulative distribution function, or CDF, is complicated. To get around this, tables of probabilities have been developed from the standard normal distribution. This is a normal curve that has been transformed so that the mean is 0 and the standard deviation is 1. The values of the standard normal distribution are called Z rather than X, also known as the Z-scores or standardized scores. So for our standard normal distribution, we have our mean to be 1 and we have our standard deviation, our mean to be 0 and our standard deviation to be 1. That means that we're going up by 1 or going down by 1 standard deviation both times. And the area under the curve is in fact 1. So for the probability tables for the standard normal distribution, they are on pages 633 and 634 of your textbook. There is also a copy of them that looks like this on Canvas for you guys, and I will be using these for the examples. So what these values represent is the area to the left of or less than the z-score, and the row labels show the z-score to one decimal place, and the column labels show the second decimal place. So for our example, what we have is, for the standard normal distribution, use the table to find out the probability of the z-score less than or equal to 0.6. So if we look here, we have 0.6, and we are trying to find 0.6. So 0.6 is this row here. And 0.6, we're just doing it when the mean is 0. So 0.6 when the mean is 0 is 0.7257. So that means that this, in highlighter, this equals 0.7257. Now for so the 0.6, what that stands for is that there's the first decimal place. If we had a second decimal place like we're going to have in our next example, that's when we go across. So the probability of z is less than minus 1.83. What we have to do here is find where minus 1.8 is. So minus 1.8 is in fact here, and then we go across to 0.3. And so at 0.3, it is here, and so it's 0.0336. So 0.0336. For C, we're finding the probability that z is less than 2.34. So we go to our table, we go to 2.3 on our left-hand column. So 2.3 is here, and then our probability was 2.34. So we have to go to our 0.4 to get our answer of 0.9904. For D, we have the probability that z is greater than minus 2.7. So what we want to do for this is it is equal to 1 minus the probability of z is less than or equal to minus 2.7. So we need to find what the probability of z is less than negative 2.7. So we go to negative 2.7 on here. 2.7, because there was no second decimal point, it is just the value of 0.0035, and we're going to take that away from 1. So it will be 1 minus 0.0035, and so what that equals is 0.9965. For our last one, we have the probability of minus 0.3 is less than or equal to z is less than or equal to 1.4. So what this equals is the probability of z is less than or equal to 1.4. Take away the probability of z is less than or equal to minus 0.3. So we need to find these two values. So we go to 1.4. There was no extra decimal point. So we're just talking about this value here of 0.9192. 0.9192 minus negative 0.3, so that's on our negative page. So negative 0.3, again there was no second decimal point, so it will be 0.3821. So when we put that into our calculator, so 0.9192 minus 0.3821, we get our answer to be 0.5371. Now to talk about quartiles, deciles, and percentiles. So for a standard normal distribution, use the table on page 633 and page 634, or on the attached document on Canvas to find the median. So what the median does is it separates the bottom half of scores. So we want them to find the score with the cumulative probability of 0.5 in the table. So if we go to our table, I'm just going to erase everything on my table. And we're looking for 0.5. So 0.5 is this value here. So it means it's the z-score of 0. So that means our median equals 0. For the lower quartile, it separates the bottom 0.25 or bottom 25% of the data. So we have to find the values that are close to 0.25 in our table. So if we look in our table, we're looking for 0.25. Now, I can't see one on our positive page. So if we look on our negative page, 0.25. So I get 0.25, just having a look. I have this value here, some values here. So, not that first one, but we definitely have ones either side. So we have the values that match up with negative 0.67 and negative 0.68. So we need to work out which one is closer and then approximate it that way. So we have the probability of Z is less than or equal to minus 0.67 equaled 0.2514. And we had the probability of Z is less than or equal to minus 0.68 equaled 0.2483. Now we're going to work out which one is closer. So the 0.2514 is closer. So therefore the lower quartile is approximately minus 0.67. Now for the upper quartile, that separates the bottom 0.75 or 75% of the data. So we want to find the point where it's closest to 0.75. So if we look on here, 0.75, we have these two values here. So we have 0.67 and 0.68. So we have the probability of Z is less than or equal to 0.67, which what that equaled was 0.7486. And we had the probability of Z is less than or equal to 0.68, which equaled 0.7517. So now we need to work out which one's closer, and 0.7868 is closer. So therefore the upper quartile is approximately our 0.67. Now it would make sense that our minus 0.67 and our 0.67 are the positive and negative of each other with our lower and our upper quartile. Finally, well not finally, for D we want to find the 84th percentile. So that separates the bottom 0.84 of the data. So we're looking for 0.84 on here. So there's 0.84 there, and then here is 0.8389. So it will be the probability of Z is less than or equal to 0.99 equaled 0.8389. And we had the probability of Z is less than or equal to 1 equaled 0.8413. So we have to work out which one's closer. And for this, the 0.8389 is closer to 0.84. So for the 84th percentile, it is approximately 0.99. Then the 6th decile is our last one, and it separates the bottom 0.6 of the data. So if we look back at our table, so 0.6, so we have 0.597 and 0.6026. So this is the probability. I've done that every time. The probability of Z is less than or equal to 0.25 is equal to 0.25, 0.5987, and we have the probability of Z is less than or equal to 0.26, and that is equal to 0.6026. So 0.5987 is closer to 0.6, so therefore the 6th decile is approximately 0.25. Then for question 5, we have to shade the area above, or the area of the normal distribution where the values are, for A, above the top 20% of the data. So we have the probability of Z is greater than A equals 20, and we have the probability of Z is less than A equals 80%, which equals 0.8. So on our table, we're trying to find 0.8. So if we go back to our table, again, I will just erase this. So 0.8, that is 0.8 here and here. So we have 0.84 and 0.85 are our two options. So it's the probability of Z is less than or equal to 0.84, which equals 0.7995, and we have the probability of Z is less than or equal to 0.85, which is equal to 0.8023. So we have to work out which one's closer, and 0.7995 is closer to 0.8 than 0.8023 is. So that is where we want to draw. So we're going to draw it at 0.84. So we need our line at 0.84, and we want to colour in the space above. So the space above it is this space here, is what we want to colour in or shade. Okay, and above the top 10% of data, and I believe this is the last thing that we're doing, so that's the probability of Z is greater than A equals 10%. So that's the probability that Z is less than A is equal to is equal to 90%, which equals 0.9. So on our table, we want to find 0.9. So 0.9 occurs here and here. So 0.8997 is closer than 0.9015. So we're going to write that one down. So the probability of Z is less than or equal to 1.28 equals 0.8997. So our line is going to go at 1.28. So that is roughly here, and then we're going to shade this part of our graph in. We must also write that this is the point 1.28, and back up here this was the point 0.84.